All right, in this example, we have the Mitsubishi Motor Company logo. It tells us that the logo is made up of 3 congruent rhombi, but then there's that empty space, which is the white triangles there. Each rhombi has a side length of X centimeters, and they're all congruent to each other. So in a rhombus, all 4 sides are equal. We have 3 congruent rhombi, so we're going to mark all of the sides, and they are X units long. Each of those is X units long. So X is not the entire base of the triangle, it is the side of the rhombus. So each side of the rhombus is X units long. All right, so our goal is to determine the area of the red part of the logo. So just to see the logo better, I'm going to outline the entire logo. And then we'll name the vertices A, B, C, and A, B, and C. So let's just start up here. Let's label that point A, point B, and point C. So in a rhombus, the opposite angles are congruent. Both pairs of opposite angles are congruent because a rhombus is a parallelogram. So if I go to the rhombus in the bottom left, I'm going to mark both pairs of opposite angles congruent. Okay, the same thing is, well, since all the rhombi in this example are congruent to each other, then I don't have to switch the angle markings. I just have to identify which pair corresponds. So the angles that appear to be acute here, right, I'm going to mark those over here as being congruent because the rhombi are congruent. And then I could do the same thing in the rhombus on the top. All right, well, now if I look, it says angle A is congruent to angle B, which is congruent to angle C. So the measure of angle A is equal to the measure of angle B, which is equal to the measure of angle C. But there are 3 angles of a triangle, and they're all equal to each other, so they must all be 60 degrees. So that means that this the logo is an equilateral triangle. The entire logo is an equilateral triangle with a side length of, so that side length is equal to this side length, which is equal to this side length. That could be important in one of the ways to answer this question, but it's not going to be that important if we go another route, and I'm gonna go that route first. Since each angle is 60 degrees of that equilateral triangle, then in each of the rhombi I have a 60-degree angle. Well, if I draw in the diagonal that doesn't bisect 60 degrees, so I'm going to draw in the diagonal that bisects the other angle, I have an isosceles triangle because of the congruent sides with a vertex angle of 60, which means the base angles have to be the same. So in this case, the base angles both have to be 60. So this rhombus is actually formed by 2 equilateral triangles. Well, that's going to be true for every single rhombus around here. So the other rhombus over here is formed by 2 equilateral triangles. The rhombus on the top is formed by 2 equilateral triangles. So that means that the area of the red part of the logo, the area of the red is formed by 6 equilateral triangles of side length X. Well, this should be really easy to solve for because now we have an equilateral triangle formula and we have 6 red equilateral triangles. So the area of the red must be equal to the side squared times root 3 divided by 4, and then there's 6 of those, so multiply multiply that by 6. So the area of the red portion of the logo is equal to 6x squared times root 3 divided by 4. 6 divided by 4 is 3 over 2, so the area of the red is equal to 3x squared root 3 divided by 2. There is another way to get the answer, and it's going to kind of go along with what I had marked up here, but we didn't use the fact that the largest triangle was equilateral. Because in the rhombus, this angle is 120 degrees, then its consecutive angle must be 120, because in a rhombus, like a parallelogram, consecutive angles are supplementary because of the parallel lines. So if that angle is 120, then this angle up here would be 120, then this angle is 60, and this angle is 60. So it was probably your guess that those the white triangles were also equilateral, but that's an easy way to prove that those white triangles were also equilateral triangles. And since those were equilateral triangles, then they have a side length of x as well, right? Because two sides of them are, two sides of the equilateral triangles are also side of the rhombus. So that means that each side of the largest of the logo, each side of the logo in this case is 3x units long. So if I wanted to think of area of the red as like the area of the entire figure minus the 3 white triangles, we can set it up that way as well. We could do the area of the red is equal to the area of the entire logo minus the area of the 3 congruent equilateral white triangles. So the 3 congruent white triangles. Okay, so let's kind of set that up. So the area of the red is going to equal, well, the area of the entire logo is an equilateral triangle with a side length of 3x. So the formula would be the side length squared, which is 3x, so 3x squared times root 3 all over 4. And then I have to subtract away 3 white equilateral triangles with a side length of x. So that formula would be side squared times root 3 divided by 4, but there's 3 of those white triangles. So that's how I'd write the expression for the area of the 3 white triangles. Well, now just a little bit of arithmetic cleanup, and then write our final answer. So 3x squared, that means we're going to have 9x squared root 3 divided by 4 minus, this is going to be 3x squared root 3 divided by 4. That difference is going to be 6x squared root 3 divided by 4, which sounds familiar. So the area of the red portion should be 3x squared root 3 divided by 2. Clearly, you don't have to do both options, but I just wanted to give more than one possible way to go about this problem. I hope that was helpful.